Hey guys, what's up? Welcome to the next video set and problem set. This one is going to be all focusing about acids and bases. So this first video is going to be covering how to determine what's like a strong acid versus a weak acid. And yeah, and so it's going to be relying on four main factors, okay? So first, let me just draw out the general scheme of an acid-base reaction. Okay. And so let's just quickly analyze what I wrote on the right. So we have an acid, and that H right here is what's going to be given up by the acid. Remember the definition of a acid is that it's going to be giving up a proton, or at least one of the definitions. So the acid is going to give up a proton to the base over here. All right, and the base we just drew a lone pair and a negative charge. Doesn't always have to have a negative charge. All right, and so let's just draw the curved arrows for this. All right, I'm going to go like this. And then this bond is going to now break to the acid. All right, so the acid now takes a lone pair and is negatively charged, and the base has now that hydrogen. Okay, and so I wrote here that this is A minus, what do you call it? A with a negative charge, and this is still B, right? But what used to be an acid here and a base on the left, on the product side, is now going to be what's known as a conjugate base. All right, because if we look at on the right now, this acid can now act as a base. It has a lone pair and a negative charge, so it can react again and grab that hydrogen, and the reaction now goes to the left. Right, so now on the right hand side, it's no longer an acid, it's now a base. And same for this over here, it's now going to be a conjugate acid. Okay, and so when we have an acid-base reaction, the acid becomes a conjugate base when it gives up the proton, and the base becomes a conjugate acid when it takes the proton. All right, and what drives acid-base reactions, or in terms of what makes something acidic, is the stability of the conjugate base it forms when it gives up the proton. Okay, so if I have a acid that when it gives up a proton is extremely stable, then it is going to be a very strong acid, all right, because it wants to be more stable. And if the conjugate base is stable, it will not react again to form the acid. All right, so if I just write this is stable, that conjugate base is stable, it will not react to form that acid again. Okay, and if it was unstable, if the acid gives up a proton and the conjugate base is extremely unstable, then it will react again to form the acid, and so it will be a very weak acid, all right, or maybe not acidic at all. All right, and so let's get started. So I wrote the four main factors on the left hand side of what determines acidity: the atom that is being deprotonated, if we can resonate, induction, and orbitals. All right, and I'll explain all four of them, and they take priority as in this, so number 1, 2, 3, 4, and I'll explain what I meant by that priority. So first, let's start with factor number 1, the atom that is being deprotonated. All right, so there's two cases when we're comparing when we're comparing acids such as this. We have this structure on the left and this one on the right. We have they're trying to indicate for us to focus on the atom, on the hydrogen connected to the atom of interest, right? So in this case, you can see it's the oxygen, and over here is going to be the nitrogen. All right, and so oxygen and nitrogen are on the same period or row on the periodic table. And so on the test, they can ask you between these two compounds, which is the stronger acid. All right, and so your first step is to draw the conjugate base of that acid. All right, so let's imagine that there's some base over here, right, and it's going to take that hydrogen and it's going to break that single bond and go onto the oxygen in the form of a lone pair. So we're going to have now that negative charge in the oxygen. And remember, it's got 3 lone pairs if you forget. And same for this nitrogen here. So now we're going to get so now this nitrogen has a negative charge also. All right? So those are the conjugate bases of these acids. Okay? And so now our job is to determine which is the most acidic one. The left-hand molecule, right, which is called an alkoxide, is just an oxygen that with a negative charge and some carbon chain connected to it. Or we have this nitrogen compound, right? It's called an amine. So when we have atoms on the same period, what we use to determine what is a stronger acid is the electronegativity trends, okay? As we go from left to right on the periodic table, electronegativity increases. And the same holds true if we're going up the periodic table, all right? So when an atom is more electronegative, it is better able to stabilize a negative charge. The more it's better able to stabilize having more electrons, all right? So if we look at the periodic table, which you can just do in your laptop or computer or whatever, the oxygen is is to the right of the nitrogen. So the oxygen has higher electronegativity than that nitrogen, and thus can stabilize that negative charge much better than the nitrogen can. All right? So that means this conjugate base is more stable than that one. All right? And so remember what I said before, that when an acid gives up a proton, if the conjugate base is stable, it is considered a strong acid. It is not maybe a strong acid, but it is acidic. Okay, and so between this one and this one, the conjugate base of the alkoxide is more stable than the amine. And so that means that because it's more stable, it is more readily giving up a proton and is therefore more acidic also. This is also more acidic than that one. All right, and so on the test, if they were to give you this question, we would pick the structure on the left as being more acidic, okay? Because when we're comparing two things on the same period, we look at the electronegativity. All right, and so the one on the left is going to be the more acidic one in terms of that. That's more acidic. The acidity referred to the structure in the acid form, not that conjugate base form. All right, so that's the trend when the two atoms are in the same period. When they're in the same group, which is a column on the periodic table, it's going to be a little bit different. All right, because while electronegativity increases as we go up, that is not going to be the driving force of the acidity in this case. And so on the test, they could ask you which of these two molecules, right, are going to be the more acidic ones. So we have this alcohol group over here. We also have this SH group, which is called a thiol, right? It's the sulfur version of an alcohol. And so first step, again, is to just draw the conjugate base. So here, I'll just draw like a little base over here, another one over there. And so this is good curved arrow practice. You're going to draw the hydrogen, okay, deprotonated, same here. And so now we're going to be comparing this conjugate base with the sulfur conjugate base. All right, so remember that the whole point is that the more stable your conjugate base is, the more readily the original acid will give up a proton to form that stable conjugate base, and therefore the more acidic it is. All right, and so if we look at electronegativity, this oxygen is higher up on the periodic table than the sulfur. So we would think that it's going to be more acidic, but it's not. All right, because when we're talking about within columns, we now have to consider the atomic radius trend. All right, if you remember that, if we have if we have a periodic table, our electronegativity is going to trend goes like this. Right, but then the atomic radius trend is going to go this way. As in, if we go down or to the left of the periodic table, our atoms will be getting bigger. All right, and so the atomic radius gets bigger as we go to the bottom left of the periodic table. And so if we look at the periodic table, sulfur is below the oxygen, right? And so sulfur is going to have a larger radius. And so sulfur has a larger radius, or if it helps, just think of it as size. All right? And so oxygen right here is smaller than the sulfur. Okay? And so what does this actually do to the stability of the conjugate base? Well, if I drew this little radius over here, right, this could be around the oxygen, but then the sulfur could almost be like this. All right? And so because sulfur is bigger, all those electrons that it has 3 lone pairs right now, we can spread them out over a larger distance, all right? So by spreading those electrons out over a larger distance, they're not so tightly concentrated in one spot, okay? And that spreading out, or delocalization, which is the word you'll most often hear, that delocalization ensures that the electrons aren't going to be essentially repulsed by each other, right? When we have a negative charge and a bunch of electrons in a very tightly concentrated region, there's going to be a lot of repulsion between them because like charges repel each other, all right? And so your whole goal in terms of determining the stability is to try to get your electrons to be spread out. So since the sulfur is larger, it'll be able to spread out those electrons more, and thus the conjugate base is more stable. Because the conjugate base is more stable, the original acid right here is going to be more acidic. So this thiol is going to be more acidic than that alcohol group on the left. Okay? And so this is going to be our answer in terms of which is more acidic. So in summary, the two trends for atoms are going to be if it's going to be more electronegative. So if we're looking at atoms in the same period, we look at electronegativity. More electronegative is going to lead to more acidity. If we're in the same group, then we're going to look at atomic radius, all right? And so if the atomic radius is going to be bigger on one than the other, then the one that is bigger or lower down on the periodic table is better stable in the conjugate base form, and so is therefore more acidic in its acid form. In the next video, we're going to be covering the other factors. If anything here didn't make sense, please feel free to contact me or go to the CLC with TA office hours. They'd be happy to help you guys. And also, of course, there's also the problem set for you guys to practice that I'll have up on this. And I'll see you guys in the next video.